السلام عليكم ورحمة الله. طلاب شعبة اللغة الإنجليزية الفرقة الثانية كلية التجارة جامعة المنوفية. Already we started introducing numerical descriptive measures, and today we have a third lecture in the same topic, how we can summarize data using some numerical measures. Before we introduced, in the first lecture, actually, we introduced central tendency measures. We introduced the position and the location measures. In the second lecture, we introduced the variation of the spread measures, range, variation, variance, standard deviation, and the mean deviation. And we introduced the Chebyshev theorem and the empirical rule. Today, inshallah, we need to, somehow, to introduce some points. The first point that I need to introduce first, how to calculate the mean and the standard deviation from the frequency tables. But today we have some points. We have mainly 3 points. The first point, how to calculate mean and standard deviation from the frequency tables, from the grouped data. The second point, the skewness coefficients, one measure we can use to decide the distribution of the data, is it skewed or symmetric, skewed to the right or skewed to the left. The third point, I need to add one graph, we name it as the box plot based on the quartiles. Today we are finalizing the topic in numerical descriptive measures. We need to finalize how to calculate mean and standard deviation from the grouped data. What we had before, you are using the ungrouped data to calculate central tendency measures and variation measures. But today we add one point. If you have group data in frequency table, if you have a frequency table and you need to calculate the mean and the standard deviation, how we can do that? That's our point today, the first point today. The second point, if you have data, we can calculate one coefficient. We name it as a Pearson coefficient measure to decide that our data is symmetric or skewed. And the last point, based on the quartiles, we are introducing one graph. We name it as a box plot. In the same way, the box plot, it's very similar to the histogram, and somehow similar that we need to find out the distribution of the data. By using a box plot, we can see the distribution of the data is symmetric or skewed, and we can check if you have somehow outliers in your data. The outlier mean you have extreme or very large values or small values in relatively to the entire data set that you have. We name it as outlier. One value very far from the left side or the right side in your data set. Okay, so the first point, how to calculate the mean and standard deviation from the grouped data. We had before, that we covered before. If you have ungrouped data, individual or raw data, then you calculate the population mean at the sum of the values divided by their number. And we had that application before. The second case, if you have sample data, we said x bar equals sigma x over n is still the sum of the values divided by their number. We covered that, but from the ungrouped data. We name it as ungrouped data. For the variance and standard deviation, still for the ungrouped data, you can find the variance as sigma x minus mu all squared divided by n if you have a population data. But if you have a sample data, then divided by n minus 1, sigma x minus x bar all squared divided by n minus 1. What we can observe now, we have raw data, it's individual values. We don't have any frequency data or frequency table for the data. Now, we need to calculate the mean from the grouped data. What is the meaning of a grouped data? That means we have a frequency table. Now, if you have a frequency table and you need to calculate the mean from the sample data, then sigma fm divided by n. F, the frequency values. If now the frequency values, and m, the midpoint for the class of the data that you have. If you have a frequency table, that imagine now we have frequency table, the first column, as we said before in our lecture, that the first, if you have a quantitative data variable, that you have a class. The class is somehow intervals, and then you have the frequency. For each interval, now we have the frequency. So now that the class, you can find the midpoint. We can find the midpoint for each class, and we name it as m. Okay, so now how to calculate x bar? Sigma adding m now as a one column for each class, for each interval, we have the midpoint. And then we have for each one, you have f, so that you can multiply f times m. You can add another column, we said is f times m. F times m for each two values now correspondingly are multiplying them. And the sum of fm divided by the number of values n now, the number of the sum of the frequency values. So the sum of the frequency values now is the value n, the number of observations that you have. Very simply, we can apply that directly. Now, without any details, we can apply that. If you have a frequency table, you can add two columns, one column for the midpoint for each class, and the second column, the frequency times the midpoint, and then adding them up will give you a numerator for the x bar, sigma f times m. That means the sum of the multiplication of the frequency times the midpoint divided by a number of the frequency. Now, number of the frequency equal n. n, the total number of the frequency, yes. Sigma f, as we said, and fm, and then that the explanation for all what explained. Okay, so direct application, to simplify the idea, direct application. Now we have one frequency table. That frequency table we have in first class from 15 to less than 18 and so on. And we have for each class we have a frequency. And now for that table, calculate the value of the mean, or calculate the average of the selling price. What is the average of the selling price from that frequency table? To answer that question, I have to add one column for the midpoint for each class and find the m times f and so on. So now we can answer that directly, very simply. That's the idea. So that the frequency, now we are adding one column for the midpoint. For the first, the midpoint m, for the first interval, we have a maximum 18 and the minimum is 15. So that very simply 18 plus 15 divided by 2 will give you the midpoint 16.5. Second interval, we have 18 and 21, and minimum 18 to 21 in maximum. Then 21 plus 18 divided by 2 will give you a midpoint equal 19.5. So now the width of that interval is 3. So 3 divided by 2 is 1.5. So 15 plus 1.5, 16.5. And then 18 plus 1.5, it's 20, it's 19.5. And 21 plus 1.5 is 22.5, and so on to the last one. 33 plus 1.5 equal 34.5. The midpoint, which means the mid of the interval that you have. How to calculate? Maximum plus minimum divided by 2. Then we have a midpoint. And then the third column, find the frequency times the frequency. Each value of the frequency times the midpoint will give you fm. So now 8 times 16.5 equal 132. And 23 times 19.5 equal 448.5, and so on. Then adding them up will give you numerator, that sigma fm. So that adding them up will give you sigma fm, so that the numerator. So now to calculate x bar sigma fm, so that the value divided by n, a total of the frequency values equal 80. Then the average from that frequency table, the average now of the selling price equal 23.1, well, unit in thousands, then 23.1 thousands. That's how to find out the mean from the frequency table, or we can say the grouped data. In the same way, how I can calculate the standard deviation, I have to modify a formula for the standard deviation to be able to find out the standard deviation from group data. So just we can remind you that for the S from an ungroup data, it was indeed, we can write that down very simply. The S from an ungrouped data, it was sigma, of course, the square root, sigma x minus x bar all squared divided by n minus 1. So now we don't have a value of x, but we have a midpoint. So instead of m of x, we are using m. And now for each value, for the midpoint, you have frequency. Then we have to add the frequency outside the squared deviation. Okay, so now sigma f times m minus x bar all squared divided by n minus 1. So to find the standard deviation from the frequency table, you have first to find the x bar from that frequency table in the same way as we had before. As we had in the last example, you have to first to find the x bar from the frequency table, and then we are applying that idea. So now we can apply that very directly from one application. So assuming this data. Now, the same data, of course, the same data, just to simplify the idea. So now how to calculate standard deviation? First, that the class and the frequency values. To calculate the mean, we calculate the mean before we had the mean equal 23, as we 23.1. Okay, the x bar, how to calculate the x bar? As we said, we have an X bar equal sigma F times the midpoint, يبقى that's the summation, divided by N or sigma F. So now we have a midpoint. We had before F times M. The last example, we have F times F, M, and then we calculated that values. So now to calculate the variance using this formula, I have to find M, the midpoint, minus X bar. So each value of the midpoint minus X bar, and we said the X bar in our application 23, as we can remember now, 23.1. That's the value of X bar. So M minus X bar, each value in the midpoint minus the X bar, it's 16.1 minus 23.1 equal negative 6.6, and so on to the last value, 34 minus 34.5 minus 23.1 equal 11.4. That M minus X bar. Indeed, we need to square the values. يبقى M minus X bar, then squaring the values directly, and then each value times the frequency. يبقى each value, that 43.56 times the frequency, 8 will give you F times M minus X bar squared. Doing that for all the values. For all the values, and somehow we can find the numerator for the standard deviation. So that now sigma, that value, sigma F times M minus X bar all squared, substitute in this formula, will give you the standard deviation equal 4.4. Then the X bar equal 23.1, that to present in somehow how to calculate the center or the typical value. If typical value or the selling price equal 23.1 with the variation around that center equal 4.4 thousandths. We have the measures in thousandths. So now in general, most of the values of the selling price between 23.1 minus or plus 4.4, and according to the empirical rule, most of the values between this interval, which means 68% of the values in that interval. So I can summarize, but in general, based on that idea, in general, if you need to calculate the mean and the standard deviation from the frequency table, first you have to find the midpoint, and accordingly are using midpoint and the frequency values to find the mean and the standard deviation. In the same way, we can find the variance. Okay, so now variance, just the formula for the standard deviation without the square root. Okay, so that's the first point. In the second point, if you have data, how we can decide the data about how we can decide about the distribution of the data, how we can decide the data is skewed or symmetric. We can use the Skewness coefficient, our Pearson Skewness coefficient, as we said before. So second point now, how I can calculate the Skewness coefficient, regardless of the software now actually. So the Skewness coefficient in general equal 3 times X bar minus median divided by the standard deviation. If you have data and you need to decide, the data is skewed or symmetric, then calculate the Pearson coefficient of Skewness that equal 3 times mean minus median divided by the standard deviation. So now step 1, you have to calculate mean, median, and standard deviation. Step 2, substitute in this formula. So now what we can say in general about the value. If you have the mean equal, if you have a mean equal median, then you'll find the value exactly of the Skewness equal 0. So if you have the Skewness equal, if you have the value of the Skewness equal 0, then you have perfect symmetric distribution. There is no skewness in your data. If your data symmetric or perfect symmetric, if you have an SK equal 0. And if it's very close to be 0, yani the value is very close to 0 or near to be 0, yani approximated to be 0, then you have nearly symmetric distribution. But if you have the value, it's very far from 0, it's close to positive 3 or close to negative 3, then you have skewed data. If it's positive, then you have positive skewness. Okay, if you have a value it's positive, then you have positive skewness, and if you have a value negative, then you have negative skewness. That means if you have an SK positive value, then you have the data skewed to the right, and if you have an SK as negative value, then you have skewed to the left. And if you have a value of SK exactly 0 or close to be 0, then you have perfect symmetric or you have nearly symmetric distribution. So in general, we are using that formula to decide about the distribution of our data, and we can visualize that. We can say if you have the SK equal 0, then you have symmetric data. If you have an SK positive, then you have a skew to the right data. If you have the SK negative, then you have a skew to the left data. In some applications, actually, we have two centers, and we say bimodal data. That it's not. I don't need to discuss this point now, so we can say in our course, mostly we are discussing these 3 points. So you are calculating the SK, and based on the value of the SK, we can decide if it's exactly 0 or near to be clear or close to be 0, then you have symmetric data. If you have positive value and close to be 1 or greater than, or and somehow we can say it's very far from 0 and positive, then we have a skew to the right. And if it's you have negative value, then it's skewed to the left. Okay, so that in somehow based on the Pearson coefficient skews. In some data we can apply that. You have data and we need to calculate mean, variance, standard deviation, and then we need to calculate the skewness coefficient. So that the data for this data, the earnings for 15 values, need to calculate mean. We need to calculate mean, median, standard deviation, and we need to calculate the coefficient of skewness to decide about the shape or the distribution that we have for our data. So very simply, how to calculate the mean, sum of the values divided by their number, how to calculate the median, sort the values and find the value in the middle, how to calculate the standard deviation, applying a formula for the sample data, without details about the calculation, because we had that before. So now just we can find out in X bar, sum of the values divided by their number equal almost 4.95. Standard deviation equal 5.22. How to calculate a median, sorting the values and find the value in the middle, you'll find it almost actually 3.18. So now SK equal 3 times X bar minus the median divided by S, or standard deviation, equal almost equal 1. So now because the value is positive and it's a little bit far from 0, then we have a skew to the right data. So now what about the shape or the distribution of the data? Now it's skewed to the right because you have SK positive and it's greater than the value 0. That's the second point, how we can decide about the distribution of the data using the Pearson coefficient of skewness. The third point, or the last point in our lecture now, we need to discuss, based on the quartiles, we can introduce one of the very important and useful graphs. It's very close to the histogram. We name it as a box plot. So indeed, a box plot, it's one graph. And that graph, you are visualizing the data using the quartiles. So if you have data, you calculate first the minimum, you calculate the maximum, you calculate the Q1, you calculate the median or Q2, and based on these 5 values, you can visualize. First, you put the scale of the data, according to what you have, assuming that like the x-axis, okay, that the values. And based on that values, you decide the location or the position for these 5 measures. For the minimum, maximum, and the 3 quartiles, you can decide. And then in general, the box plot actually, we can in somehow, I need to discuss that in details. So for the data, if you have data symmetric, so that the box plot in the case of the symmetry, I'm now assuming that the x-axis now. And then if you have symmetric data, you'll find a Q2, that box. Why we named it as box plot? Because we have box including the 3 quartiles, and then you have lines for the minimum and maximum. Okay, so that Q1, that based on the x-axis values, that is scale. So that Q1 and the value in the middle, exactly in the middle, Q2. If you have symmetric data, then exactly in the middle, okay? And then you have a Q3, so that the box, and that for the minimum, and that indeed for the maximum. So we name it as a box plot. So if you have symmetric data and you are visualizing the quartiles in that way and using the minimum and the maximum, then you'll find it that the shape indicates if you have symmetric data. Otherwise, assuming if you have a skewed to the right data, so mostly you'll find, okay, so now assuming that the box, and then you'll find, because Q2 in the middle and you have skewed to the right data, then you have the length of the tail from the right, it's actually larger than what you have left, and that's the minimum, and that the maximum value based on the x-axis, and that the Q1, and you'll find the Q2, it's not in the middle, it's actually close to Q1, it's closer to a Q1 than a Q3, okay? So that if you have skewed to the left, skewed to the right, sorry. So that positive skewness, that symmetric data. And then in the same way for the box plot to visualize the data, you can have one box that for a negative skewness, assume that. So that negative skewness, I'm approximating the idea, okay? And I'm approximating the idea. So that assuming that the minimum, that the maximum, and that the same way that the Q1, the Q2, the Q3, and find the Q2 closer to Q3 than Q1, and then we say we have negative skewness or skew to the left data. But I need to add to the histogram. The histogram can be used to visualize, and you can show the distribution of the data, yes. In the same way, we can use 5 measures to visualize the data and somehow check the distribution. We name it as a box plot. Now that one application saying that you have 15 values, we calculated the minimum, maximum, and now we need to use a box plot and somehow to visualize the data and decide about the distribution. About the skewness coefficient to decide about the distribution, a histogram can be used to decide about the distribution, the box plot can be used to decide about the distribution, okay? So now the answer for that, it's very simple. The other slide, so that the scale for the x values, now the minimum around actually, we have the scale from 12 to 32 to include all the values, that is scale, and somehow we have a distance to values, and then that the value of the Q1, the value the Q2, the median, the Q3, and based on that, now the main information after plotting or visualizing the box plot, what you can observe from that box plot, we can observe that we have a skew to the right data. So now assuming the histogram for this data can be that way, okay? So that mostly to be accurate, and somehow to be accurate that the middle, okay, that the median mostly in the middle, and then mostly will be that the histogram in that case. If you are plotting the histogram, it will be mostly in that way. So anyway, so we can say histogram and the box plot, we can use them to visualize the data and decide about the distribution. So based on that box plot, now we have positive skewness or skew to the right data. To finalize our lecture today, first we explained how to calculate the mean and standard deviation from the frequency table. Second, how we can decide about the distribution of the data using the skewness coefficient or Pearson skewness coefficient. And last point, we add based on the quartiles, one graph, we name it as a box plot style to decide about the distribution of the data. Our lecture, the third lecture for the numerical descriptive measures. Now we finalize chapter 3 and chapter 4. Thank you very much for all of you.